Thank you, Professor Schiffman, for such an interesting talk. As expected, we do have a lot of questions coming in from the participants. So without any further ado, let me get started with the Q&A session straight away. The first question, Professor Schiffman, is about whether the antibacterial surfaces be influence whether the target bacteria is gram positive or gram negative. Is there any influence on the fabrication of antibacterial surfaces?
Absolutely. And I guess I just want to start by thanking everyone for the comments in the chat. And I've looked through all the Q&As. I'm not sure I get to pick, but they're fantastic. So yeah, we didn't talk about this too much, but there is certainly some tailoring in how we design a surface to specifically target gram positive or gram negative. While some antibiotics and even some natural essential oils do target bacteria non-specifically, mean they work for lots of different bacteria. Some are very specific to some bacteria and not to others. So for example, in the case of the chitosan amine groups, in our case, worked non-specifically to kill both gram positive and gram negative, although they have a different efficacy, so different percent inactivation. When we think about something like cinnamaldehyde, that's really known to specifically target the gram negative Pseudomonas bacteria, and it's not known to specifically target certain other bacteria. So while it might work, it's not as effective. Some of the targeting is due to the membrane structure, the two membranes versus one membrane of the gram negative versus gram positive. And some of it we might not totally know yet why it works better in one bacteria versus the other.
All right. Yeah. Thank you, Professor Schiffman. So the next question is about the efficiency of the cationic polymers that you showed for antibacterial applications. And the question is, certain metal ions are reported to have antibacterial properties in literature. So what is the efficiency of such metal ions or their complexes as compared to that of cationic polymers?
So this is a great question. So we have made some surfaces with the metal ions, such as silver. We have one paper where we actually electrospun cellulose nanofibers, covered them or grew zeolites on the surface, and the zeolites delivered single ions of silver. It was really an elegant paper that we were quite proud of. So the metal ions are very effective at killing bacteria, especially the single ions diffusing. When they're able to diffuse through the membranes of the bacteria, they can kill. However, certain metals, like silver, bacteria have shown resistance to them. So while they're still effective today, they might become less and less effective in the future, meaning we would have to use more of them in order to kill the same amount of bacteria. Yeah, metal ions are quite effective, but we want to be a little bit safe.
All right. Yeah. The next question is about polyethylene glycol, and if the chain length of PG have any effect on the anti-fouling activity of the films.
Yeah, so this is a great question. So there's a lot of studies that have shown the effect of molecular weight, and my current understanding is that there is a minimum molecular weight that's needed in order to have the anti-fouling effect. In our case, it was quite interesting. So for example, when we looked at membranes, if we used a molecular weight that was too long, it would inhibit the flow of the water through the membranes and clog the pores. So for that case, we had to stick to a shorter backbone, maybe 5K, 20K also works, something like that. So in our case, I would say there are preferable lengths, but sometimes we have to balance different properties, such as performance of the material with the anti-fouling property as well.
All right. Yeah. Thank you, Professor Schiffman. The next question is from a participant who is especially interested in implants. And the question is, how feasible is it to generate nanotopography of the types you described on curved implant surfaces?
Oh, that's a challenge. That's certainly a challenge. I have talked to some companies that will remain anonymous about how to scale this kind of technology. And I will say it is definitely a challenge. So in some cases, we're trying to understand, does the topography really have to be as specific as when we make it using nano imprint lithography? And I don't know the answer to that yet. So using a process like nano imprint lithography is very expensive, but maybe now that we understand some of the spacing, some of the requirements, we could generalize it and make the topography using a different method. And so in this case, yeah, we're just trying to balance that fundamental understanding with, I love it, with these translational, how do we move towards this real life application?
All right, yeah. So the next question is about zwitterionic polymers. And the participant is asking if the zwitterionic polymers affect the healthy cells, particularly for dental care.
So maybe you were reviewer number 2, whoever asked this question. Yeah, so we don't fully know. So some people, there have been many studies that have looked at how Zwitter ions impact different mammalian cells and different parts of the body. But we don't have the capability to look at, to look at, I don't know how to call it, but like digestion studies with mice and things like that. We haven't done anything like that. So we actually looked at the Zwitter ions do not kill any bacteria. We looked at our Zwitter ion copolymers. They don't kill any bacteria, but I think we would have to look at how they impact other kinds of cells and if they encourage different kinds of bacteria to grow that wouldn't normally grow. So there's some longer term impacts that we haven't looked at yet.
All right, thank you, Professor Schiffman. So the other question is about 3D printing techniques, and the participant is interested to know whether 3D printing can be used to fabricate the polymer materials that you showed, and if actually by 3D printing we can achieve that resolution that is needed for the desired topography that you described.
So, the last I've looked, the resolution does not go with traditional 3D printing. The resolution can't go down to nanometers or as low. However, I'm not an expert in this area. I know other people are, but there certainly have been great advancements in 3D printing, both in terms of getting to smaller resolution and also doing really cool things like encapsulating cells inside of hydrogels. So I guess we'll have to look into the ACS database for another scientific talk on 3D printing. Sorry, I can't give you a more specific answer.
Yeah, thank you, Professor Schiffman. So the next question is about the participant is interested in knowing if these materials or polymers work for controlling extracellular polymeric substances. And there's a follow-up too, if there are multiple bacterial colonies or cultures, are the efficiencies affected?
Wow, this is a fantastic question. So that extracellular polymer matrix is that goo that the bacteria prevent. And so we have developed some assays in our group in order to characterize that EPS, but we actually got a little distracted in our work of looking at the early attachment of bacteria. And by distracted, I mean, we've done less work at looking at the growth of the greater biofilm. That's actually something that's ongoing work. I don't know. I would have to get back to you, but I do think that some of these, let's say cinnamaldehyde natural agents, they are going to impact the overall structure of that biofilm, but I don't know what it will upregulate and downregulate in the bacteria. With that being said, that also ties into the second question. If you're using an antimicrobial that targets one bacteria, we know that in the body, many bacteria are synergistic or they live off of each other. And so if you're decreasing one bacteria, you could actually be increasing a different bacteria. So we really do have to look at that more readily.
Yeah.
So I guess the short answer is probably, and I would love to study that more.
Yeah. Thank you, Professor Schiffman. So I think we're already beyond time, but I'll take the last question on the journal, actually. So the participant is interested in knowing, is description of a figure of merit or a comparative analysis versus prior publications something that is really essential for acceptance of the submission in ACS Applied Engineering Materials?
Yes, I think this is a very important question to ask. For most applications, I think it's really important to put your work in context. You might not need a whole separate figure, but if you're going to say that your chitosan remediated 99% of the copper metal ion, I need to see how that compares to how other people in the past have used chitosan to remove metal ion. So without some comparison group, it's really hard to evaluate how successful the application is. I'm not going to say every single paper needs it, but I think most papers would really benefit from having this comparison group.
Yeah, absolutely. Thank you, Professor Schiffman. I guess that is all from the Q&A session. Thank you once again, Professor Schiffman, for the wonderful talk. And if you have any closing remarks for the audience, please feel free.
Oh, thank you so much. I think you know where to find me on the internet. Please submit to the journal, and for anyone that has a PhD in a related field, if you're interested in serving as a reviewer, I would encourage you to complete the ACS Reviewer Lab, and then we'd love to have you contribute to reviewing and, of course, submitting papers. So thank you so much.
Thank you, Professor Schiffman. I'd request Kunal to please take over.
So thank you so much, Mihir, and thank you, Professor Schiffman, and thank you to Kaushik as well for collating the questions. As Mihir mentioned, that we still have a large number of questions that are remaining, and we apologize to the audience that the time is always limited. So we'll try to bring back Professor Schiffman on the ACS Science Talk, as she has given a teaser for some new research that is coming out of the lab. So we look forward to having you again. And with that, this brings us to the end of today's session. We hope that you have enjoyed this broadcast. We invite you to view the edited recordings for the past events in the ACS Science Talks library. At the end of the session, you will receive a brief survey. A link to that has already been posted in the chat. So kindly share your feedback with us so that we can continue to improve and serve you better. On behalf of all of us at ACS, thank you for joining us today. We hope to see you again soon for more ACS events. Until then, stay safe and healthy.